Okay guys, hopefully making a quick little video here on solving 3x4 matrix systems using Gaussian elimination, but these systems are either going to have no solution or infinitely many solutions, and we'll see the difference between those. So I have a system here, and I already put it into an augmented matrix. I pretty much do the same steps every time, but you don't have to go in this order. So my first goal is to get this first entry to be a 1. So I can do this by dividing the first row by 2. I could subtract, right, or negative row 1 plus row 2 would be an option. I could do 2 times row 1 and then subtract row 2. So there's a lot of options here. I'm just going to go with the division option. So I'm going to do row 1. Oh, gotta get my pen back. Row 1 divided by 2. I know it'll give me some decimals, but I don't mind dealing with them. And you guys can use a for function or even your calculator just to help add and subtract if we need to here. Alright, so this is what my first row turns into. And I haven't changed any other rows yet, although I kind of could at the same time, because I'll use the last row here. So I want to next get zeros in these 2 rows. So I'm going to use the last row, and I'm going to do 2 row 2 plus row 3 to get a 0 here in this second row. So that'll give me a 0 here. 2 row 2 would be 4 plus 3 is 7. Negative 8 plus negative 3 is negative 11. 8 plus 2 is 10. All right, so that's our row 2. I haven't changed row 3 yet. All right, so my next goal is to get a 0 in this last position, and I'm going to use row 1 for that. So I'm going to go 6 times row 1 plus row 3. I'll take a second to write out my entire matrix here. And you'll see sometimes I get lazy and don't put the dotted line, but that's okay. All right, so my first position is going to be 0. 6 row 1 would be negative 3 plus 3 is 0. 6 row 1 would be 3 plus negative 3 is 0. 6 row 1 is 3 plus 2 is 5. So as soon as we get to a matrix like this here, we should stop and think, because right now this last row is telling us that 0 variables, there's no x's, there's no y's, and there's no z's, equals 5. And if we ever got that in an equation, well, that wouldn't be possible. So at this point we can stop and say there's no solution. All right, so whenever we see on the left side of that dashed line, right, our variable, if our variables are 0, we've got a number on the other side, that's something that is not true. So that's a system with no solutions. And I'm going to just throw right into this video a system with infinite solutions. I'm going to pause my recording really quick to write it out. All right, back to our new system here. And I just wrote out the system and the augmented matrix here. And again, there's a lot of options on how to start this off. But I always start by trying to get a leading 1 up in this top spot. The other option would be to try to get zeros in the first column and then that middle bottom entry. But to do this for this one, and I don't think I've done this before in any of my examples, I'm actually just going to switch row 1 and row 2. So as my reason, I'm going to put row 1, swap with row 2. And then just rewrite my matrix that way. So now I'll have the leading 1 up top. We notice the system is all 0 constants, which is a little strange, but that's okay. All right, so I'm going to do the next 2 steps at the same time. Since we have both 3's down here, I'm going to try to clear those out. So I'm going to do negative 3 row 1 plus row 2, and negative 3 row 1 plus row 3, and clear out those bottom entries in the first column all at the same time. So I'm just going to write out my matrix. Oh, my new matrix. And I would suggest maybe pausing and trying it out on your own, and then just checking with my steps. I'm going to go kind of quick for this one. So this is what I have so far, and maybe we're starting to notice right now that that second and third row are multiples of each other. So I am going to keep going as usual and get this guy to a 1. And while I'm at it, I'm going to actually divide that last row out just to make things smaller. So I'm going to do row 2 divided by -5 and row 3 divided by -10 just to clean things up a little. And now we should really notice that the second and third row are the same here, but I'm going to go on and clear out this 1, and when I do that, so if I do negative row 2 plus row 3, this whole last row is going to turn into zeros. So at this point, I'm in row echelon form, I'm all set, and I'm going to write out what we have left of this system back as equations. So I've got x plus 2y minus 3z equals 0, and then y minus 2z equals 0. So if we see there's no equation for z, and we have 2 equations for z with z equals, so this means since we kind of lost a variable there, this is an infinite solution case, but we can solve this system, or we can get x alone and y alone. So I'll have y equals 2z. From the top equation, x equals 3z minus 2y, and this would be an infinite system because z then could be anything. I've defined everything else really essentially in terms of z. So for example, if I pick z equals 1, then for this system y would equal 2, and x would be, let's see, a 3 minus 4, so a -1. So you could pick any number for z and get values for x and y. So we'll write out the answer to that system. Again, we can either just leave it like this, where we've defined all 3 values, or as always, we can write it as a coordinate 3z minus 2y, y is equal to 2z, and then z would just, I would say z is anything, or z is any real number. All right, and we're all set.